Alright, so the goal of this question here is to prove that the left side equals the right side. So we'll be starting with the left side of this equation. So the first thing we're going to do is expand out the tan y and the cotangent x. So we know that tan is equal to sine over cosine, and we just need to add the y's at the end of each of those. And we know that cotangent is equal to 1 over tan, meaning that it is the opposite of tangent, which would be cosine over sine, adding the x on the end of both of those. This is the right side, obviously. So once we've done that, we can now multiply these two numbers together, these two equations together, and with that we get sine y times cosine x over cosine y times sine x. Okay, so now we have to expand out the 1 so that we're able to add that onto what we already have. We can do this by having the same numerator as denominator. So I'm going to make the numerator and denominator both cosine y times sine x. This allows us to be able to add these two numbers together. So now once we've added these two numbers together, we get cosine y times sine x plus sine y times cosine x all over cosine y times sine x. As you can see, they on the previous line both have the same denominator here and here, so you're able to add these together. So now once we have that, this is all we're going to do for the right side of this equation. Left side of this equation, as you can see here. We're going to now move on to the right side. So now with the right side, or sorry, the left side. Now, no, right side. Now with the right side of this equation, we have sine bracket x plus y over cosine y and sine x, which if you notice is the same denominator as what we had on the left side at the end. This means you're probably going to be working with the top of the numerator. Now, because of this, the formula that we use with sine, we know that to expand this here, to expand that, we know that it actually expands out to cosine y times sine x plus sine y times cosine x. Putting it over the bracket, putting over the denominator that we had as well, cosine y times sine x. It actually looks, we get the exact same on both sides, proving that these two are both equal. And that's how you prove that these two are equal.